Hello and welcome back. So far we have understood the binary class classification and used SGD classifier. The SGD classifier algorithm's backbone is the logistic regression. We understood how logistic regression works. And then we understood how to take control over the model's decision by using the decision score and threshold and playing with the threshold and all those things. So let us try to understand what is multi-class classification and how to build model and look at accuracy and error metrics and all that stuff. So multi-class classification can distinguish between more than two classes. Suppose there is a data set like this. There is x1, x2, two input variables, and y is a target variable, triangle, circle, and rectangle, three classes. The data belongs to three classes. And when you pass this train set to the algorithm, it should understand the pattern, and when you pass a new record, the algorithm should be able to predict or classify which class it belongs to, either it is triangle or circle or rectangle. So the algorithm is going to do a decision boundary like this, as shown in this image. So by default, random forest and naive-Bayes algorithms are capable of doing multi-class classification. There are other algorithms also. If you look at scikit-learn's API, you can find all the algorithms which support multi-class classification. But if the algorithm is not supporting multi-class classification, like support vector machine or logistic regression, there is an approach, there is a solution for that. The one versus all and one versus one are the algorithms on top of the SVM and the logistic regression. They work and they help the algorithms do multi-class classification. By default, scikit-learn implements one of these, one versus all or one versus one, when the algorithm is incapable of doing multi-class classification. Why two algorithms, one versus all and one versus one? When the algorithm, if you take SGD classifier, it's a stochastic gradient descent classifier. So stochastic gradient descent classifier can handle huge volumes of data. If the algorithm can handle huge volumes of data, then one versus all is the algorithm it's going to use. If algorithm is incapable of handling huge volumes of data, like SVM, support vector machine cannot handle huge volumes of data, then one versus one algorithm is used. So we will understand what is one versus one and one versus all in coming session. But let us try to jump in and see how to do a multi-class classification using SGD classifier. As I said, when you use SGD classifier, scikit-learn automatically picks up the one versus all algorithm and implements it. So we will understand how to write code and build a model and make the model the best on a multi-class classification first. Once after understanding it, we will actually see what is one versus all and one versus one. So let us jump into the code and see how to do it. So the same theory is present here. I have imported some modules which are needed, and then I read using read CSV. I loaded the digit recognizer dataset. The digit recognizer dataset or the MNIST dataset, MNIST dataset, has got multiple labels on the target variable. The images are belonging to different handwritten digits. The handwritten digits range from 0 to 9. So the label is going to be from 0 to 9. So we have 42,000 images in the train set, and we splitted that train set into X and Y because the algorithm needs the data to be passed in X and Y format. And then we splitted the data into train test and test set. For test set we have taken 20%, and train test split will do a stratified sampling based on Y variable. When I say stratified sampling, it is going to pick up 20% records belonging to 0 and put it aside as test, 20% records belonging to 1 and put them aside as test set, 20% of the records belonging to 2, put them aside as test set. Like that, all 10 classes, it will pick up 20% records and put them aside as test set, and remaining 80% is going to be there on train set. So we are going to use train set to build our model. So before we use SGD classifier, we need to apply standard scaling, because gradient descent algorithm always expects data in similar scale. So I have taken standard scaling. You can use min-max scaling also, and then did fit transform. When I do fit transform, on each column we have 784 columns in the X, and label is the Y variable. On each column, it will take mean and standard deviation and calculate z-score of each value. On the pixel 1, pixel 0, it takes mean and standard deviation. It subtracts mean from this number, divides by standard deviation. Subtracts mean, divides by standard deviation. Subtracts mean. If you do that, all the data may come to a range between -1 and 1, or maybe -2 and 2, or -3 and 3, like that. So that is called as z-score in statistics, and standard scaling actually does that. On a train set, we are doing fit and a transform. When I say fit, it is going to calculate mean and standard deviation of each column. And when I say transform, that's when it calculates the standard scaling or z-scores of each value and then puts it into the same way. Digitex train is the variable name. Now I have imported the SGD classifier from linear model module. And then I am passing random state is 42. I think you remember, you can give any random state, any number. There is no need that you should give 42 only. The random state variable actually keeps the random variables generated by the algorithm to be constant. First time they get generated randomly. From next time onwards, it is going to be constant. And I have taken log loss here because when we build a model or when we train a model, what is training? Algorithm.fit is the training. When you take the algorithm, this is just an algorithm, and then algorithm.fit will actually take the X and Y, the input and output, and tries to understand the pattern. What is pattern there? In logistic regression, the hypothesis function is 1 by 1 plus e power minus z. What is z? The linear equation. It is going to find those thetas. When you say fit and pass x and y, it is going to find those thetas. When you say fit, that's when the finding thetas happen. That's when the algorithm becomes a model. Once after passing x and y and fitting, the algorithm becomes a model. So now it became a model. I have taken log loss here because on a model, if you want to see probabilities, by default, every model gives you decision scores. But if on a model, if you want to see probabilities also, you need to use log loss only. If you use hinge loss, by default, the algorithm uses hinge loss. If you use hinge loss, it's going to give decision scores only. What is decision score? The distance between the decision boundary and the data point. If you want probabilities, you want to see probabilities. It is just to see probabilities, that's it, right? So if you want to see probabilities, you need to use log loss. So I built a model here, or I trained a model by passing the X train and Y train. Now I can actually make prediction. To make prediction, what I did is I took one record from the dataset. X train 6735 is the index. And I have taken one record and I am reshaping it as 1 minus 1. When I reshape it to 1 minus 1, right, it becomes a two-dimensional matrix. One row, I don't know how many columns you create. Right? So when I say 1 minus 1, it's going to become a one row matrix. Why is it this needed is, when you train the model, you passed a two-dimensional matrix as X and a one-dimensional array as Y. So while prediction also, you should pass a two-dimensional matrix as input, even if you have only one record. So here I have only one record and I am passing it to predict. So I reshaped it and I passed it to predict, and it predicted that record belongs to 3. So, this is easy, right? This is same as, binary class classification. We did not do anything, much there, right? We have taken the algorithm, we applied standard scaling to the data, and we just did fit, and it is able to predict. But internally, when you use fit, the scikit-learn algorithm takes one versus all algorithm, and then it takes SGD classifier and does many calculations. We'll see what are those calculations in next session. But that's what happens. So when I say predict, it predicted. If you pass whole digit X train, it is going to make prediction for all records in the train set. Okay. Now if you want to see the probabilities, the method to see all probabilities is predict proba. In the previous session we already understood that, but if you say predict proba and pass the record, this sum record, this whatever record belonging to 3, I passed it, I've got 10 probabilities here. If you count, right, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Why we got 10 probabilities here? Because there are 10 different classes in the target variable. For each class, there is going to be a probability. For one record, I've got 10 probabilities. For each class, there will be a probability. Whichever probability is high, the record belongs to that particular class. Here, this is 0 almost. This is also almost 0. E, here you can take it as 10. 10 to the power of minus 174 means it's almost 0. 10 to the power of minus 242, it's almost 0. But if you see this, right, 1 and e to the power of 0, what is that? It is 100% probability we have got, right? So rest all are kind of almost 0. If you see minus, 10 to the power of minus 110, 10 to the power of minus 153, they are almost 0. And only one class has got one probability. That means the record belongs to this particular class. What is this class here? The first probability belongs to 0. The second probability belongs to 1. Third probability belongs to 2. Fourth probability belongs to 3. So the index is the prediction there, right? The index is the prediction because for each class the index and the class is same in this particular problem. Okay, so for each record there is going to be 10 probabilities. If you pass 42,000 records, it is going to predict for each record 10 probabilities. Whichever probability is high, that record belongs to that particular class. I hope you understand. So decision function, it gives you decision scores. What is decision score? The distance between the decision boundary and the data point. Okay, so the decision function actually gives you 10 probabilities again. For each class, it's going to give probability. See this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wherever the value is high, the record belongs to that particular class. So if you see this, fourth value is high. That means 0th index, first index, second index and third index. So 3 is the class for which the record belongs to. So by looking at the probabilities or decision scores, we can make a decision, but internally it is using an numpy.argmax of the either decision scores or the probabilities. If you pass decision scores like this, right, it is going to give you the index 3. When you use argmax method in numpy, it gives you the index of the value where the value is high in the numpy array. So the internals we are trying to understand how exactly the logistic regression is making prediction. It is generating probabilities or generating decision scores. Using argmax function, it is finding the proper class the record belonging to. So that is about how to build a model. In the coming session, we will understand how to do error analysis. And once after that, we will understand 1 versus R and 1 versus 1 algorithms. Thank you.